Hi, my name is David Wickett. I'm a senior analyst architect with SDK. SDK is a boutique analytics consulting company who help our clients leverage their data assets to strategically move their business forward. One of the many benefits we bring our clients are analytics accelerators. Based on industry best practices, these accelerators help clients build out their data platform in a more cost-effective, repeatable, and sustainable manner. Today, I'll be presenting SDK's approach to the Azure Data Platform. The Azure Data Platform is a cloud-based platform accelerating past traditional structured data analytics, enabling the capabilities of semi-structured, streaming, and advanced analytics. That's a lot in one sentence. Let me break it down for you. So cloud-based means that the infrastructure and applications are hosted on the cloud, eliminating the need to purchase and support hardware and software. You kind of think about it as renting the storage and compute, and we can scale up and down as you need it. Accelerating past traditional analytics means that we're doing more with the structured data that we used to get in the past. We can use it for advanced analytics, we can stream it for near real-time updates. So even the traditional analytics you're using today, we can get a lot more out of it. But data today is much more than the structured data we have in the past. IoT devices, social media, industry data are all new data formats that can easily be brought onto the Azure Data Platform for analytics. And these can be integrated with your traditional data sources to enhance the information you're getting out of your data. And then finally, all of these data sources can be leveraged for advanced analytics. And really the sky's the limit in terms of what you're able to do. Predictive analytics, machine learning, simulation, sentiment analysis are just a beginning of some of the different possibilities. So let me talk specifically about the benefits of the Microsoft Azure platform and its versatility. So one of the things that I think attracts people most is the scalable infrastructure. And in the case of Azure, what they've done is they've separated, in most cases, the storage and compute services. So with scalable storage, you only pay for what you use, and it allows unlimited growth, but you don't have to buy that in advance and plan to figure out where your data is going to be in 5 years' time. You just, as you consume the data, the space continues to grow. And as your data gets larger and larger, you can manage your storage layers between hot, cold, and archive storage layers to manage and control your costs with a finer grain of detail. Scalable compute is probably the one as developers we get the most excited for. You pay for the power you need at the time you need it. So if you have high utilization periods, very intense ELT processes overnight, you can scale up the report, you can scale up the compute to meet those immediate demands. But then as you go into quiet periods, you can scale that compute capacity down and only pay for what you need at the times you need it. And the benefits of this, in addition to having the power available, quite often it can really increase your performance times. So even though you're maybe paying for twice the amount of compute, you're only paying for it for half the time. So these are some of the great benefits. Also, the overall scalable solution. So unlike traditional packages, you had to kind of commit to a series of tools and packages within this. With the Azure platform, you subscribe to services and applications as you need them. And so as your data needs continue to evolve, all those applications and services are there, and those offerings are constantly growing. And you just take advantage of those tools when you need them. And if you're done with the tool, just turn it off and stop paying for it. You're not into long-term commitments for the use of these tools. And then the other part is the maintenance piece. You know, the cloud is great in terms of minimizing the amount of maintenance. One of the huge things is making sure that your hardware and software is constantly up to date. So with Azure applications, they are constantly auto-updated and they're patched behind the scenes without you knowing, and they're guaranteed to be backward compatible. And from an overall capability, these patches are available on the cloud quite often months, if well ahead of when they become available on premise. So and in addition to just the patching what's already there, new features become available. You don't need to go through an upgrade path. Those features typically become available without you needing to do anything on your side. And finally, Security and compliance. Initially, I think most people were worried about their overall security within the cloud. I think the cloud has become the most secure place to maintain and manage your data. It's very proactively managed. They have specific tools to go in and manage and micromanage that security layer as well as the overall platform. And if you're in an industry that does have industry security standards that need to be met, in most cases, the Azure platform already is meeting those standards and can provide the necessary documentation and support to meet those external requirements. So it's not all nice and simple on the Azure cloud platform. Bottom line is the Azure cloud platform is a development platform, and it can be configured and implemented thousands of different ways. What we've done through our dozens of implementations on the Azure cloud platform is we have identified some common pitfalls. One of the areas is in the data preparation area. So this immediately becomes a garbage in, garbage out type scenario. So if you're not doing your data preparation correctly, you're ending up with inconsistent storage schemas, duplicate data, poor data profiling, poor incremental processing. All of this leads to a data swamp, which increases storage and development costs overall. And then if your data is bad at the beginning, it's going to be bad throughout the application. Implementation standards, this really bodes towards what is the quality of your data, how is it supportable, everything else. And if you don't have proper development standards, proper branching strategies, proper code reusability and automation, as much as you end up with a data swamp, you can also end up to a certain extent with a development swamp as well. So we help to make sure that that process is nice and standardized. And finally, process and tools. Again, there's dozens and dozens of tools within the Azure platform. I think getting those and making sure that you pick the right set of tools, making sure that you have proper deployment processes, proper governance around those tools, proper orchestration around those tools really leads to ensuring that you've got good data quality, overall solution quality. And if that's not done, then your user acceptance and trust on these tools goes away immediately, and it's very difficult to get back if you've done that. All right, let's move on to how does SDK approach the Azure Data Platform. So we kind of see three kind of main pillars within this. The successful implementation of an Azure Data Platform is really a balancing act between client-specific requirements, making sure you've got a high data quality, high data solution quality, and making sure that you're doing that by balancing your overall development and support costs. And at the same time, we want to make sure that we're avoiding some of the common pitfalls we just mentioned about a cloud data platform. So let's look at the first component of that. Let's look at client-specific requirements. So at SDK, we look at requirements from much more of a holistic point of view. We just don't look at the specific technology requirements. What we want to do is make sure we really have a strong understanding of your data analytics data analysis requirements, not just today, but also into the future, and not just for your hardcore business analysts. We want to make sure all the way up to the C-level, all the way down to your data analysts, that they're meeting the data requirements of them as well. We also look across all your consumption patterns. So you've got people who want to dive in, get into the details, do high-level data analysis, all the way up to your C-level resources that want to make sure everything's aggregated up to a dashboard level. We look at how each of those different groups wants to consume. Do they want to consume mobile, on-premise? How do they want to do it? And even beyond that, we also look at external user groups as well, and in terms of how they might want to use it. Security, making sure that we're meeting your security requirements is key. That may include things like single sign-off, may get into things like PII data, and then just overall making sure that we have the necessary control around your data access and reporting. What's key in terms of client requirements is making sure that the solution meets the resource skill sets of the people you have. So if you have a low-code IT environment and they're supporting a lot of applications, don't have the capability to develop really deep skills in the tools, then we can focus on kind of low-code type preferences. But we also want to take a look at the skill sets of not only your technical people, but your functional teams as well. And then an extension of that is making sure that we identify any gaps between the solution we're implementing and the current skill set, and making sure that we've got training paths to make sure we get there properly. And then finally, we want to make sure that we're building a solution that allows you to grow into some of the more sophisticated advanced analytics capabilities. And so even though some people aren't necessarily ready for that, we want to make sure that you're positioned to move in that when your company is ready to do that. The second component is really making sure once we define the requirements and know what we want to build, is making sure that what we build is has high data quality and also high solution quality. So the data quality is really a bit of a balancing act between the development process and standards and strong client involvement. So development process and standards is where the accelerators that I talked about at the very beginning of this presentation really come into play. So we have data accelerators around the ETL processes, and these are ensure that you have consistent, repeatable processes, but they're also configurable enough to make sure that you can have built-in and customized data quality. We have Power BI accelerators on the reporting side to make sure that you've got a framework that drives the storytelling and meets your requirements. And then we have a job manager tool, which ensures that all of these ELT processes are proactively managed, that everything's tied together, and you have the right visibility and escalation paths in case something doesn't necessarily go right. But we can't have really good data quality in ELT processes if the data doesn't meet the client requirements. So making sure that we have really strong involvement, that the users, the end users of the data, the ones that are really driving data acceptance and providing that necessary validation. If you don't have that strong involvement, then you can generate great data that's completely accurate, but nobody wants to use. So it's really a strong balancing act between the two. And then finally, overall high solution quality. This is making sure that you're managing development from day one and making sure that you have that level of consistency. So we have developed coding and naming standards, we have Power BI accelerators, we have a data DevOps, which ensures that the code is properly managed, version control, that we have proper merging, branching strategies. All of this is necessary to ensure that you have a high quality solution that's repeatable and sustainable. And so let's take a look at the third component, which is, okay, how do we do all this and making sure that we're minimizing development costs and minimizing our support costs long term? So by SDK bringing coding, naming, accelerators all to the table up front, that means that our overall development efficiency is increased. A good example is we have an extract template that instead of having to repeat multiple times for every single data source you bring in, it's really just a configuration tool. So in a matter of days, you can bring up 10, 20 different extracts, whereas in a traditional fashion, it'd be 2 or 3 days per extract to build that development. And the other accelerators are in the same fashion, are really designed to increase the efficiency of your actual development activities. And then if you've got this really strong set of code and it's been gone through these really strict standards and everything's consistent on the development side, then the support side is far less complex and you're working with a higher quality data. So they don't need to learn as many different solutions. They can focus on one consistent, repeatable solution. If you have a high quality solution, then the number of tickets you're going to raise, and even the tickets that are raised, are much easier to resolve because you're working through a consistent, repeatable process. And all of this, and as well as some of the other items noted on here, all work to ensure that you're getting this highest quality solution, but at the lowest possible cost. All right, so this is a lot for one deck. So I think you've got the idea of the overall approach that we take towards it. This is just a representative example of an Azure Data Platform. So if going from left to right, we have a solution that's designed to ingest pretty much any type of data source you want. whether it's IoT sources, traditional database sources, semi-structured data. All of these can be ingested in, and they can come through on a streaming basis. They can come through batch, near real time. It's really up to you. What's kind of core is that it all gets moved into a common data storage area. And the bronze versus silver versus gold here is really the evolution of the quality of the data. So bronze data is really raw data. It's whatever comes from inbound sources. Some's going to be good, some's going to be bad. What we have in the silver layer is really a data quality verified version of that data. So we get rid of duplications, we look for bad records, we clean data up so that we have a constant silver layer that everybody is available for general consumption. But typically at this level, the integration between the different source systems not there. Everything's still at a source system level. So moving into gold is where we really get into that primary consumption layer where the data has been curated and formatted for general consumption from across the organization. And then as you move forward, that gold data can then be moved into an enterprise data warehouse. We've shown Azure Synapse here, but there's a whole variety of different data warehouse options that are out there in the industry and offered on the Azure platform. And then finally, the final layer on insights is really consuming that data. Once you've got this structure in place and you've got all this great data in your data storage layer, then the ability to add on incrementally or all at once, your choice, the different areas of advanced analytics. So whether it's machine learning, simulations, those can be added in, but all your data is sitting there ready to be used and consumed by your advanced analytics team. And then where the accelerators all kind of come into place is really throughout this overall process down into orchestration, security, etc. If we move to the next slide, I can kind of show you where the different SDK accelerators fit into the overall solution. So if we look at the advanced analytics layer, we have a machine learning ops offering, which ensures as you complete your POCs on the advanced analytics area, we ensure and make sure that you can move these into production in an efficient way and ensure that these models are constantly maintained. If we get into the data ELT layer, we have data accelerators that take the data all the way from the source systems through the data warehouse. And then that gets extended with our Power BI accelerator to ensure that the quality and the development efficiencies are attained at the insights level as well. And then we have coding standards and templates. From a development standards and automation, we have a data DevOps offering accelerator that will move you towards CI/CD. On the orchestration side, we have a job manager tool that ensures that all the transformations, everything across the platform are properly managed. And then we also have standardized security templates to ensure that we can secure this environment and in accordance with your specific requirements and industry best practices. So overall, that's the SDK approach to the Azure Data Platform. I want to thank you very much for listening to this today, and we look forward to you reaching out to us in the future.